Hello, my name is David Ehrbar. I'm the designer of the Serpent F110 SF4 Formula 1 car. And I want to show you how to rebuild the damper. So first I will open it up. There's only one screw that you need to open and close with a tool. Okay, just open up here. Remove the oil. I try to avoid using any brake cleaner or other solvents on the damper, as I want to, those solvents are not, many times they are not good for the seals and the O-rings, so I try to get those parts only in contact with silicone oil. Okay. I show you one very nice feature of this damper. The damper has under the ball joint, you have a bleeding hole, or opening. It's drilled in the middle of the M3 thread, and we have a small hole on the side of the thread, so you can get excess oil out, or we can set the internal pressure or rebound of the damper. Okay, so before I install oil, before I fill up the oil, I need to close this, because otherwise the oil will just come out. So I use the Ehrbar 700 Sandy-Stoke oil. Put it into the housing. You don't really need to fill it up completely, so you can see here I just keep it a few millimeters below the upper limit. Remove the air. Okay, while I wait for the air bubbles to escape, I will explain you why I use such a small damper on this car. I mean, the reason is the damper is the highest part of the car, and of course I want to keep the center of mass or center of gravity as low as possible. So the uppermost part, it needs to be as light as possible. So on the Formula 1 car, the center shock, it works on the whole rear end, so it needs quite some damping force. And the way it is designed is, on the conventional shock you have the membrane on the upper part. So when the piston goes into the shock, so on compression, the membrane has to keep the oil in place. So but because there's no pressure behind the membrane, basically you always run the damping force is limited by the by the ambient pressure. So ambient pressure times the piston area is basically the maximum damping force. And if you make a smaller damper, like I did it here, you would not have sufficient maximum damping force on compression. So I turned the principle around. I have on the compression side, I have nothing like a membrane. It's just solid on this side. So when the piston moves in, the force is basically not limited. And when the piston moves out, the volume compensation, it acts on the other side. On the here's a small foam foam piece inside for the volume compensation. But this is on the rebound side, so it only ever sees the force of the spring, so there cannot be like a really huge from a bump or whatever. The maximum force it can see is the one from the spring. So in this configuration, the maximum damping force is just higher on the compression, so I can use the smaller diameter to make it work in the same way and save some weight and keep the center of mass as low as possible. Okay, so as the air bubbles have escaped, I will install the piston with a volume compensation cartridge. I just put it in slowly from the side so the air can escape. I try not to trap air under any of these parts. Okay, and before I fully tighten it, I open up the lower side. So I mean, if I would wait for an hour now, the oil would escape on the lower side, but of course I don't wait that long. So I just tighten the upper side, and you see I have the piston still maximum on the outside at the moment. I will clean it a little bit so you will see what happens. Right now, if I close the lower side now, I have rebound on the damper. Basically, if you wait some time, it rebounds basically to the position where the piston was when I closed the lower side. So if I don't want internal pressure or rebound in the damper, I will just put the piston wherever I want to have it and open the lower side. You can see that some oil is leaking out here. This is just the excessive oil. It don't really take long. It's like 1 or 2 seconds is already enough. I clean it up again, and now you see I have like almost 0 rebound. I can also make it to exactly 0 if I open it again now, but as the car never reaches this position, it will end up soaking in air, because the O-ring seal is much better to keep internal pressure from the oil inside compared to keeping air from entering. So it's better to have at least a little bit internal pressure, and have the I try to have the rebound setting here at about 1/3 of the length. So I will install the spring. It takes a little bit practice to install it with a low rebound setting. It's much easier with high rebound because you need to compress the spring. I show you. You need to, either you need to compress the spring and put everything on later, like now, then you have everything free here. This is one possibility. And the other is you can get the 1.5mm wrench between the windings of the spring and install it like that. It's basically the more, it's easier like this. There's one feature on the shaft. You can see there's like a groove here, and when you install the spring and the cap, the set screw goes into this groove. So it will be exactly it will always be at the same length. So you don't need to change or control the length every time. Okay, if you if you want to change it, and or if you turn on the ball joint here, you will change the length anyways. But you don't have to take too much care on the when you close the set screw. It will be basically in the groove. Yeah. Anyways, shock is rebuilt. It's working nice, smooth, perfect, without any air. I will install it back to my car, and yeah, see you next time. Let me know which feature of the car you want to have explained, and see how to rebuild it or whatever. Yeah, see you in the next video or at the racetrack. Bye.